All right, we're going to jump into some review of square roots. It's going to be important that we review how to handle the square roots of numbers for our next topic that we're going to be covering called the Pythagorean theorem. So we need a little review before we start. So the first task you have is to list the first 20 perfect squares. Okay, see how many you know on your own. Go out online and pull up perfect squares. Quick reminder, a perfect square is the product of a number times itself. So, So 1 squared equals 1. 2 squared equals 2. Excuse me, 4. Sorry. 3 squared equals 9, right? So these right here are your perfect squares. These are your perfect squares right here, 1, 4, 9. So take a second and make a note of your perfect squares. You should write them in this format though, because you writing this down is actually going to save you a lot of time on this entire activity. Okay, so get those down and then come back. All right, so we're going to go through and do some of the problems on your worksheet together, and then you'll work on some on your own. So we're going to do number 1, square root of 49. Okay, if you take a look at your perfect square list, you'll see that 7 is the square root of 49. And the reason that it's 7 is because I can take 49 and break it down into 7 times 7. And because 7 times 7 equals 49, the square root of 7 times 7 is 7. Another way you can look at this is I could rewrite 7 times 7 as 7 squared. A square root cancels out a square. So these two cancel each other out. If you have something squared, you cancel it with a square root. That's it. Now the next few, we start looking at some negative numbers. And so on a side note, usually if you have an answer or if you have your square root with different positive or negative requirements, we'll kind of see as we go over the next few examples. And hopefully it makes more sense. So for number 2, we have a positive and a negative in front. And this is what I mean. If you don't see any symbols out front, you can assume our answer is positive. But if you look here on number 2, we have a positive and a negative. And what that means we want both answers. So we want the positive and the negative answer. And I'll explain what that means in a second. So for 144, I want to know what times itself equals 144. So look at your list and see what times itself equals 144. It would be 12. Now, technically, positive 12 times positive 12 equals 144. But doesn't negative 12 times negative 12? A negative times a negative is positive, right? So positive 12 and negative 12 would both be the answers to number 2. And again, usually you don't have to put a sign unless it's kind of laid out in the problem like we have here. So you would want to include the positive and the negative. Number 3, square root of negative 4. As of right now, this is not possible. You cannot have a negative inside the square root symbol. Okay, in a minute, you'll see one where the negative is outside. But what this is asking me is, this is saying I need a number times itself that's going to equal a negative. Okay, so let's think about that. If we're truly trying to find a number times itself to equal what's inside, right? So up here we had 12 times 12 or negative 12 times negative 12, right? Well, for number 3, is there any number times itself that would equal a negative number? That's not possible because a negative times a negative is always going to equal a positive, isn't it? So I physically cannot do this. When you get to high school, you'll find out that there's a method to do that. But for right now, this is not possible. All right, number 4. For number 4, we have a decimal. Now, there will be times where you have access to a calculator and times where you won't. So although you could put this in a calculator and get an answer, do that to check yourself, but you do need a process on how to handle this if you didn't have a calculator. Okay, so let's think about this for a second. A decimal, 0.16, if you said that number to yourself, you would have 16 hundredths, right? So what we're going to do is I'm actually going to write this decimal as a fraction instead. 16 hundredths. Okay. Now, when you have a fraction inside a radical or inside this square root symbol, you actually are taking the square root of the numerator and the square root of the denominator. So we're just going to do that. It's the square root of 16. So if you look at your list, what number times itself equals 16? 4. 100, what number times itself equals 100? Look at your list, and you get 10. Always simplify. You end up with 2/5. Now, if you were to put this in a calculator, you would have a decimal, and that decimal would be 0.4. If we take a look at this for a second, what's the square root of 16? It's 4. The square root of 0.16 is 0.4. So there's a little bit of a connection there, and you probably could bypass all of this if you did enough of these problems. But as of right now, if you see a decimal like this, turn it into a fraction, then find your square root of the numerator and the denominator. 5 plus or minus the square root of 0. What number times itself equals 0? 0. Now, we wouldn't put the plus or minus just because there is no positive or negative 0. So your answer would just be 0. Let me fix this. All right, number 6. Negative 324. All right, if you look at your list, we need to find the square root of 324, and you get 18. Now, the negative on the outside, this is okay. That's just saying take the square root of this and make it negative because it's on the outside. So because it's on the outside, my negative stays negative, and the square root of 324 is 18. All right, so now you're going to complete number 7 through 11 on your own. So hit pause and go do 7 and 11 on your own. Come back and we will do 12 together. All right, number 12. Square root of 8 plus 1. Now, if you have some sort of mathematical calculation under the square root symbol, treat the square root symbol like a grouping symbol. Okay, I'm going to simplify inside first. We don't take square roots of things that have math to do. I get the square root of 9, and the square root of 9 is 3. Number 13. Square root of 100 over 4. Now, as we saw in the other example, this is the same as having the square root of 100 over the square root of 4. Or your other option, like I just said on 12, we can simplify what's inside first. Sometimes it'll work out, sometimes it won't. With the 16 over 100, let me back up for a second here. 16 over 100 here, that doesn't simplify to anything but 0.16. Okay, so in this case, simplifying first may not have been the best choice. But if we look at 13, do you see how 100 over 4 becomes the square root of 25? So you could handle this either way. Okay, and you'll notice that we get the same answer. So if we look at our fraction here with the square root of 100 over square root of 4, square root of 100 is 10. Square root of 4 is 2. That simplifies to 5. Now, if I simplify first, I get square root of 25, which equals 5. I get the same answer, it's just two different methods. Okay, some of you may say you like this because you don't have to think of whether it'll work or not to simplify first. Others may want to look at this and decide that you want to think about it and simplify. It's up to you. 14. Square root of 187 minus 18. So again, we'll simplify first. Subtract, say 187 minus 18 is 169. The square root of 169 is 13. Number 15. Now I have multiplication underneath the radical or my square root symbol. So we're going to do 14 times 56 is 784. Now this is not included in your top 20. So in this case, you would want to calculate using a calculator. And what you get for the square root of 784 is 28. (16) 5 times the square root of 9. Okay, so what we have here, anytime you have a number right next to something else, like if I had a parenthesis, this means multiply 5 times 5, right? If I have 5x, this means 5 times x, right? So there's nothing different here. This actually means 5 times the square root of 9. So if I treat it that way, and I remember that a square root symbol is like a grouping symbol, well, I would keep 5 the way it is, and then I find the square root of 9. Square root of 9 is 3. 5 times 3 is 15. So we're just following the order of operations, remembering that a square root symbol, the radical, is like parentheses. It's like a grouping symbol. It groups something together. Okay, 17. Square root of 49 minus the square root of 4. Now, I'm going to back up to number 14 for a second. If we look here, do you see how 187 minus 18 is under the same radical? That's why I subtracted first. Okay. Now, if we look at 17, this is actually a different situation happening because 49 is under one radical, and 4 is under a separate one. Okay, so we need to handle each of these radicals or square roots on their own. So square root of 49 is 7. Square root of 4 is 2. 7 minus 2 is 5. Okay, so you have to be very careful to make sure you're understanding what the problem is asking you to do. Okay, so now you are going to do numbers 18 through 22 on your own. I'm not including 23. You can try it as a little bit of a challenge. It'd be cool to see you attempt that one, but 18 to 22 for sure. All right, next part. Between what two consecutive integers is each square root? So we want to know between what two integers is the square root of 40. So if you look at your chart, okay, your top 20 perfect squares, we need to figure out what two perfect squares is 40 in between. Okay, so look at your perfect square list. What two perfect squares is 40 in between? Well, the closest one below is 36. And the closest one above would be 49. So my directions say between what two consecutive integers is each square root? So the first step is to find the perfect squares that it's in between. Then I find the integers. So what's the square root of 36? 6. What's the square root of 49? 7. So it's in between 6 and 7. So if you were to type square root of 40 in a calculator, you would get a number in between 6 and 7. That's what this is asking you to do. Let's look at another one. Negative square root of 90. Okay, so first we need to find the two perfect squares that 90 is in between. Well, it'll be between 81 and 100. If you look at your perfect square list, 90 is in between 81 and 100. It's as simple as that. So negative square root of 81 would be negative 9 if I look at the integer. Square root of 100 is 10. So square root of negative 90 is in between negative 9 and negative 10. All right, so turn your page over, and we're going to look at number 34. Now we have a number line, and the number line on the screen matches your paper. And what we're asked in this section, it says, write the letter that identifies the position of each square root. So I need to find for number 34 where square root of negative 3 lands on this number line. In order to do this, I have to figure out which integers number or negative square root of 3 is in between. So we're actually going to use the method that we did in the last little section. So I need to figure out which two perfect squares 3 is in between. 3 is in between 1 and 4 if I look at perfect squares, right? So the negative square root of 1 is negative 1. Negative square root of 4 is negative 2, right? If our negative is on the outside, we're good. So my number or my dot is going to be between negative 1 and negative 2. So let's locate these on the number line. There's negative 1 and negative 2. So my answer for 34 must be B. $35. Square root of 5. First thing, what two perfect squares is the square root of 5 in between? It's in between 4 and 9. So remember, we're looking at our perfect square list and trying to figure out where 5 fits. So the square root of 4 is 2. The square root of 3 is, the square root of 9 is 3. So square root of 5 is in between 2 and 3. Now here's the tricky part. It's either going to be D or E. How do we know which one? All right, so here's how we figure that out. Which number is 5 closer to? Now, not square roots, but if we look just at perfect squares, which number is 5 closer to, 4 or 9? 5 is closer to 4. So square root of 5 is closer to the square root of 4, which means it's closer to 2. Which of these points is closer to 2? D. Right? So at this point, you're going to do number 36 and 37 on your own. All right, the last part. Estimate the square root. Do not use a calculator. Okay, so no decimals allowed here. 38 is square root of 39. So through this activity, we've progressively gotten to the point where now we should be able to complete these questions. We're basically going to take what we did up above, and that will be how we start this. Okay, we're going to start first. We're going to start first by seeing which two perfect squares this is in between. Okay, we're basically just trying to narrow down where we think the square root of 39 is. So it's in between 36 and 49. Square root of 36 is 6. Square root of 49 is 7. So I know that this is between 6 and 7. But when we estimate, I want to get as close as possible to an answer. Saying between 6 and 7 isn't good enough. Because as we saw, let me back up. As we saw here, there are a lot of options between two numbers, right? We need to be a little more clear as to exactly where between 6 and 7 is square root of 39. So here's what we do. Okay, so to do that, we're going to create a number line. And it's going to start at 6 and end at 7. So I'm just drawing it right underneath here and lining it up. If you don't have room, then make sure when you draw your number line, you label 6 and 7. All right. So what I'm going to do is I'm going to make a tick mark in between for every single square root between 36 and 49. Okay, so square root of 36 comes first. Square root of 49 is at the end. So I need 37, 38, 39, 40. And I'll mark them. I can't mark all of them. There's not enough room, but I'll kind of make some parts as we go. 41, 42, 43, 44, 45, 46, 47, 48. Now, Don't stress over having these all perfectly equal. Honestly, they're not in real life perfectly equal. We just need tick marks, okay? So what I want to look for is I want to look for where does the square root of 39 fall in my number line? Well, here's the square root of 40. So this would be the square root of 39, right? So the square root of 39 is right here. So what I want to do is I want to take this number line and I'm going to turn it into a fraction. If I draw a little rectangle around it, do you see how it looks like a fraction bar? So square root of 39 is 1, 2, 3. So it's 3 parts. And if I count how many spaces I have total, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So square root of 39 is between 6 and 7, right? So it's going to be 6 and 3/13 is an estimate of the square root of 39. Now, if you actually square rooted it and then took this fraction and made it a decimal, they would be very similar. Probably wouldn't be exactly the same, but they would be so close that it'd be close enough. Okay, let's look at another one, because I know these take a little bit to get used to. Square root of 75. So let's see what two perfect squares this falls between. 64 and 81. Square root of 64 is 8. Square root of 81 is 9. I need to find where 75 falls in between. So make our number line. And my 8 is at square root of 64. 9 is square root of 81. So I'm going to go through and make my tick marks in between. I need to have like 15, something like that. And when I hit 75, I'm going to make a little note just so that I don't have to write a million square roots in between here. So 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, and then there's my 81. I was being conservative and I ended up having a lot of extra room. Not a big deal because we're not counting distance. Okay. So now what I want to do is if I can imagine this is a fraction bar, you can draw the fraction bar if you want or not. It's up to you. But I need to see where does square root of 75 fall in this fraction bar. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So square root of 75 is 11 spaces in. And I have a total of 11, 12, 13, 14, 15, 16. So square root of 75 is 11/16 of the total between 8 and 9. Okay, another way to look at this is if I subtract these two numbers, I get 16. That gives me the distance between. Okay, and 75 is 11 away from 64. Now my answer is not 11/16 because remember my number is between 8 and 9. So I have 8 and 11/16. It wouldn't be 9 because I'm not quite to 9, right? I'm in between 8 and 9. So 8 and 11/16 is my estimate. Let's try another one. Square root of 35. Again, which two perfect squares are we in between? We're in between 25 and 36. Square root of 25 is 5. Square root of 36 is 6. Let's make our number line. And the reason I'm writing the square roots underneath is just so we can keep track of our numbers here. So I'm going to count my tick marks in between, making a special note of when I hit 35. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. And then I have 36 here. So if I make this into a fraction bar, remember this is my cutoff. So remember the whole rectangle, that's my whole, that's my denominator. And then if I count how many spaces lead up to my square root of 35, that's my numerator. So again, if I made this a fraction bar, I would need to know how much of the fraction is filled in here. Okay. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be filled in to get to square root of 35. But I have a total of 11 pieces here. If I counted each piece, I'd have 11. And square root of 35 is 10 of those 11. We know it's between 5 and 6, so it's got to be 5 and 10/11ths. That's all. So you are going to do, now pay close attention because there are a couple that you're skipping. You're going to do 42, 43, 45, and 46 on your own. And that's it.